Hello again, grade 12s. In this question, we need to identify three similar triangles and then determine the value of x in the diagrams below. So, in the first diagram, part B, we want to identify three similar triangles. For us to do that, let's make our lives easier. I will call the angle at B theta, okay? We have a 90-degree angle here. That would mean that the angle at D would be 90 degrees minus theta. We have a straight line there, so that would also be equal to 90 degrees. Now, if this is another small triangle, this here would be 90 degrees minus theta, and that there would be theta. So we have three triangles there. We can do the same thing for part C, okay? Let me call that theta, and that would be 90 degrees minus theta. We're looking at the bigger triangle. Now looking at the medium-sized triangle, if we already have theta, this here would be 90 degrees minus theta, and that would be theta. So let us now go ahead and identify our similar triangles. Okay, in part B, we have triangle ABD, which is the biggest triangle there. We know that this is going to be similar to triangle CAD and triangle CBA. Note that we matched each of these triangles vertex for vertex. So where there was a 90 degrees position first, say for example the first triangle A, in the second similar triangle, I started with another 90 degrees, and in this case, it was C. In the third triangle, again, 90 degrees was my C, and so on and so forth. We can do the same thing for the second triangle C. Triangle KLM would be similar to triangle LNM and triangle KNL. Again, we matched vertex for vertex. K was your 90 degrees minus theta, and we ensured that if we started with 90 degrees minus theta, we would do the same for the other two triangles as well. Now for the second part of the question, we want to look at the bigger triangle and compare it to a smaller triangle. Let's go ahead and do this. We're going to compare triangle BAD, the bigger triangle, to the smaller triangle CAD. And we want to solve for x. So, in doing this, as I said, I'm going to compare my big triangle to the smaller triangle. Okay, let's look at the ratio in the bigger triangle and look at what we are given. I have the side BD, okay, and that would be my hypotenuse, okay? And I'm comparing it to the side that is opposite the angle theta. So the side opposite the angle theta, that would be AD. This ratio would be in the same proportion as the smaller triangle, looking at AD, because again, that's your hypotenuse compared to the side opposite theta, which would be CD. We can do this because of triangle ABD being similar to triangle CAD. BD, the length there is x, and AD is 10. Compare it to the other side. AD again is 10, and side CD is 5. When we cross multiply, we have x is equal to 100 divided by 5. Simplifying it further, x is therefore equal to 20. Let us do the same for the other triangle. Again, I want to compare a bigger triangle to a smaller triangle. Again, I'm going to be looking at the side hypotenuse and the side that is opposite theta. In the bigger triangle, I'm going to compare Km divided by KL being equal to KL divided by Kn. Now the length Km is equal to x. KL is equal to 12. Again, KL there is equal to 12. Now KN is what we need to find. What are we looking for there? That is KN. This length here is x minus 18. Let's fill that in, x minus 18. Now we're going to cross multiply. X multiplied by x minus 18 is equal to 12 squared. Distribute that, we get x squared minus 18x is equal to 144. X squared minus 18x minus 144 is equal to 0. That is your quadratic equation that you want to solve. You're going to factorize this and solve for x. X minus 24 in the first bracket and x plus 6 in the second bracket. So our potential answers, either x is equal to 24 or x is equal to negative 6. Now, x in this example was a length, so we can now conclude that x cannot be equal to 6 because x is a length. X must be strictly greater than 0. So our final answer is x is equal to 24.